So, good morning, students. Welcome in next lecture of Math F242 Operation Research. So, presently we are studying the inventory model. In that, we are studying model fifth. Means here we have the inventory control with price discount. So, in continuous of that, we have this problem. The demand of an item is 225 units per day. So, what the given to you? Here we have the demand. So it is given to you as a D, and the rate of the production is 450 units per day. So it is the A. The cost of holding the inventory is rupees half per day per item. So this is given to you as a C1. The back order allowed is half per item per day. So it is your C2. The cost of starting the production run is rupees 1000, so per run, so it is given to you as a K. The production cost per item is given to you. If you are producing less than 200 items, so unit cost will be rupees 2. If you are producing between 200 to 500, so it is 1.75, and so on. So determine the economic order quantity, that is the Q star, and economic back order quantity, B star, and corresponding time of one production cycle, that is optimal order cycle, T naught star. So from the given information we can judge this model belongs to model third plus price discount, because here we have the constant delivery rate, mm, constant delivery rate and price discount. So this belongs to model third plus price discount. So for the model third, we know these are the given information. So for the model third, we know that what is the Q naught. Q naught is root of 2 kd into c1 plus c2 upon upon c1 c2 into 1 minus d upon a. So here it is by putting the value of the kd c1 c2 and a, we have the this 600. So 600 we can see it belongs to which interval. So here if you see, it belongs 600 belongs to this interval 500 to 1000. So here we write it belongs to 500 to 1000. So we can say that what is the Q star? Q star is any value among the Q naught and left left limit of the right interval. So it is the 1000 and it is 1500. So here Q star can be either the Q naught or 1000 or 1500, where Q naught we have computed as 600. So now we compute the such that total cost is minimum. So now we compute the TCU. TCU for the model third we have seen. So TCU for the model third is C naught J D plus KD upon Q C1 C2 into Q 1 minus D upon A upon 2 into C1 plus C2. So when we compute the TCU, here we have the TCU if you compute, so it is the C naught into D plus KD upon Q plus 2 upon C1 plus C2, and here we have the C1 C2 Q1 minus D upon A. D upon A. So one time we are taking the Q as a 600. So when the Q is 600 and it belongs to interval 500 to 1000, at that time C naught is rupees 1.5. So it will become, here we take TCU, right? This is the your C naught. C naught. So it is coming 41215. Now when we instead of the 600, if you take the Q as a 1000, Q as a 1000, so it will become 1.25 into D plus KD upon 1000 plus C1 C2 1000 into 1 minus D upon A upon 2 into C1 plus C2. So this will come 378.75. Similarly, we compute for the third. So it is coming 1.20 into D plus KD upon 1500 plus C1 C2 1500 1 minus D upon A upon 2 into C1 plus C2. So this will come 378. uh, ach- uh, one mistake, it is a 366.25, and for this it is coming the 378 378.75 378.75. So from here we can see that this is your minimum. This is your minimum. So as this is the minimum, we can say that this 1000 is the Q star. This 1000 is Q star. So from here we are getting the Q star as a 1000 unit. Q star as 1000 unit. And after having the knowledge of the Q star, we know that B star is equal to Q star into 1 minus D upon A into C1 upon C1 plus C2. So when we put all the values, so you will get the Q star as a 250 and T naught star as Q star upon D. So Q star is, we have computed as 1000 upon 225. So it is coming 4.44 days. So in this way, in the price discount, we compute the optimal Q and thereafter we compute the other parameter. So this is your homework. Demand of a gas cylinder in black is 500 cylinders per day in an institute canteen. So demand is given to you as a D. Demand here is given to you as a D. The delivery rate is 1000 cylinder per day. So here it we have the A. No shortages are allowed. Means no shortages are allowed. That is the B is equal to 0. So in this case, because delivery rate is constant and B is equal to 0, so now we can say it is the model 1. It is model 1. The cost for holding is rupee 1. So it is given to you as a C1 per cylinder per day, and freight charges incurred in getting the ordered quantity is rupees 80. So it is independent of the quantity, so we can say it is K. The purchase cost per cylinder is as follows. So here the purchase cylinder is given to you. If you purchase less than 100 cylinder, unit cost is 200. If between 100 to 300, then it is 250. So you can see here, when we purchase more, you have to pay more unit price. You have to pay more unit price. So in this case, the Q star, just I am giving you, means this problem belongs to the model 1 plus price discount. Model 1 plus price discount. And in this, after computing the Q naught, Q star will be the either the Q naught and right limit right limit right limit of left interval, right limit of left interval. So with that you compute the q star, and then you can compute the t naught star. So this is your homework, right? So you please do this. Now, last two models we have the probabilistic model. Whatever the till now, in that we have studied the deterministic model, means demand is constant. Now demand is probabilistic in nature. So here we have the some special case, only single item, single period model. Means single item is, as you know, what is the meaning of the single item when we are dealing with the single item. So the, and now in new term is the single period model. So single period model is nothing. It is the short period model. It is the short period model, means this is the model in which you cannot reorder. Important is you can't reorder. Can't reorder. So here the single period inventory model occur when an item is ordered once only to satisfy the demand of the specific period item. Items which become obsolete after the certain period of time may not be reorder. May not be reorder are dealt in single period model. For example, if we have the business of the Rakhi, so uh, it is of short period, means for the 1 or 2 or 3 days only. In that period you cannot reorder. If you haven't the item, if you are shortages with you are shortage with the item, you cannot reorder, because it is such short period. You cannot reorder, you cannot get the your order. So such type of the, for example, Diwali crackers business, calendar business, newspaper. In the newspaper, whatever the order you have, that much order you have, right? You cannot order on the same day. So newspaper, perishable item, all are of the single period model. So thus the situation in these model is that the product must be produced or purchased for use or sale during the single time period. Means in this, either you are producing or purchasing. Replacement policy may be anything. But in this, main thing is you have to judge what can be the demand. You have to judge in a random way that what can be demand, and for fulfilling that demand you have to procure in advance. Before selling the crackers, you have to procure the crackers by judging the demand. In that period you cannot reorder. In that period you cannot purchase. In that period you cannot produce. So the following could be certain typical situation which can be modeled as single period inventory model. Inventory of the seasonal goods, right? Right, calendar, diary, rakhi, and all these things, such as winter cloth is also seasonal commodities, seasonal item. Diwali greetings card, rakhi, perishable item such as egg. It means that egg has the limited life length. Vegetables, sweets, short-lived item such as newspaper, Christmas tree, etc. So in this, the stock replacement occurs instantaneously. Means we assume always we have the stock in prior, right? We have the stock in prior. You cannot reorder during the period. So and here we take the, because it is the probabilistic model. So here we take the demand is probabilistic in nature. When probabilistic in nature means it is characterized by it is characterized by either the PDF or the CDF. Either the PDF or the CDF. The optimal inventory level is derived on the basis of minimization of the expected inventory cost. Here we compute the optimal inventory level by minimizing the expected total cost, as we have done in the previous models. These costs include, you know, what are the cost? That is the ordering cost or procurement cost, right? That is the setup cost plus purchasing or production cost, plus holding cost plus shortage cost. The same thing we have done for the earlier model also. Here also we compute the expected total cost comprises with procurement cost, holding cost and the shortage cost. Because demand is probabilistic in nature, right? Demand is probabilistic in nature, and here per unit purchase and production cost, though the constant plays the effective role in the cost function. So here also we compute the total cost function. So here we are saying that we have the instantaneous demand. Instantaneous demand means before starting the period, right? Before starting the period we have to judge what can be the demand. Here the demand will come one by one, but you have to judge what can be the demand, so that that much amount of item you can procure, you can store, right? So here in the probabilistic model, we assume that demand is instantaneous meaning here is you have the knowledge in prior, right? You have the knowledge in prior about the demand. You have the prior knowledge, means that much sale we can do, and it is a short period model. So demand is generalized, is generated instantaneously at the beginning of the period, means in it is a such short period in that you cannot reorder as per the current demand. So you have to judge your short period demand prior to that period. Demand is filled at the beginning of the period through the instantaneous replacement, means you complete your procurement process before the starting of the period, means during the sale you cannot reorder, during the sale you cannot procure the item. You have to procure by judging the demand in advance only. So here procurement is made before the demand is generated, means you have to procure your item, your item before, prior to the actual demand is generated. You are judging your demand, what you are judging the expected demand during the period, but demand is generating during the period only. So here no further order is possible. It is such a short period. In that period you have not to bear even the holding cost, right? So here no important point is this, no holding cost during the period, since period is short. So here what is the holding cost? Because when we say that in the total cost we have the procurement cost, holding cost and shortage cost. So here I am saying that there is no holding cost in that period. So here the holding cost is incurred over the over the ending inventory, whatever the leftover item that you have to manage, and in managing the cost, whatever the cost is incurring, that cost is termed as holding cost. So holding cost is the cost incurred in managing the leftover item. So here we have the following notation. Let's say x is the demand. It is a random variable. It can be discrete, it can be continuous. If it is a random variable, characterized by the PDF or PPF fx or the CDF capital Fx. K is the setup cost. It is independent of the quantity. So setup cost, which is constant, and it occurs only when order is placed. The procurement of the stock is achieved. The independent of number of items, right? If we are not ordering, then we say k is equal to 0. If we are not ordering, means if we are not placing an order, then we assume that k is equal to 0. Then we know that what is the c naught. C naught is the unit purchase or production cost. What is the c1? C1 is the holding cost. As I have told you, holding cost here govern only for the leftover item. So holding cost per unit of ending inventory. Ending inventory means leftover item. It is calculated over the item leftover at the end of the period. Means it is such a short period model that in that period you have not to bother about the holding cost. Holding cost, right? We have to bother only the holding cost or cost related to the leftover item. Then we have the C2. C2 is what? Stock out or the shortage cost. If we are not able to satisfy the demands are more, then whatever the associated shortage cost means loss of the goodwill, loss of the customer, loss of the revenue, all come under the shortage cost, and that we denote by the C2 unit cost, right? We denote by the C2. Then the quantity q is the quantity ordered and received instantaneously just before the period, right? Just before the period. During the period we are taking the assumption that during the period there is no order. There is no order cannot be possible. So here the q is the quantity whatever you have ordered prior to the period and you have received that much order. Means here we are not considering even the lead time. We are assuming that we have the enough inventory. We have the enough inventory to satisfy the generated demand during the period. Then after I is the inventory or initial inventory we can say, or inventory in hand. Means sometimes we have the previous year items. For example, this last time we have some Rakhi, right? We are not able to sell all the Rakhis. So what we would do? We pack them and we can utilize them as an initial inventory for the current year. So I here the inventory on hand at the beginning of the period before the order is placed. Means after you have assumed that this much can be the demand, this much can be the requirement, and this much we have in our inventory. So whatever the difference, that much only you can order. You will order. So that is the Q. Means I is the leftover of the previous period, right? So here desired inventory will become R. If you assume that R is the desired inventory level means which we have judged that during the current period this much sale we can do. So R is the desired inventory level and it is equal to Q plus I. Q is the quantity whatever you are placing plus I is the quantity whatever you have before placing an order. It is the leftover of the previous period. It is leftover of the previous period. So here we take the R is equal to Q plus I. So as I have told you in starting, in this under these condition, we have the two model 7 and model 8. So here we will study both model one by one. Model 6 is not in course, so we have skipped that one. So here we have the model 7 as a no setup cost means k is equal to 0. K is equal to 0 means there is no setup cost. You are not placing an order. Not placing an not placing an order. Not placing an order. We are taking the k is equal to 0. In this, as I have told you, x can be either the discrete or continuous. So we are considering the first case as a continuous random variable. If x is the continuous random variable, means for example oil, water, right, air, so all the oxygen, all these are of continuous quantity. For example crackers, it is the discrete in nature. Winter cloth, discrete in nature. Here we are dealing in this case, we are dealing with the item which is continuous in nature. That's why here we are taking the x as a continuous random variable. So to find the best R, what we want the best desired inventory. That is the R star. We want to compute the R star, best R, which minimize the expected total cost for the whole period. Means we want to minimize the expected total cost. So first, what can be the total cost? So total cost is nothing. Total cost. Now you can, if I'm now, please pay attention. One important thing I want to convey here, that when X is the demand, right? X is the demand, random demand, and R is the inventory level. R is inventory level. So it means when we have the situation X minus R, X minus R. So what is the significance of the X minus R? What is the significance of the X minus R? R is the desired inventory level. X is the demand. Means demand is greater than the desired inventory level. Desired inventory level. Then you have only the R item, but there is more demand. It means what is the situation? We have the situation of the shortages. We have the situation of shortage when R when R is greater than X. When R is greater than X, at that time R is greater than demand. Means desired inventory level. Desired inventory level is greater than the demand. Then you are able to fulfill the demand, and we have the leftover. We have leftover. Leftover means we have to hold. We have to hold. Right? So means both situation we cannot have. If we have x is equal to r, x is equal to r, then what is the things? Means demand equal to the desired inventory level, no shortage, no holding. So that will not affect. So in this case, the total cost, in the total cost, either we have to hold, either we have to hold, or we have to face the shortage. Both simultaneously cannot happen. Both simultaneously cannot happen because it is of the short period. Holding we are wearing, holding we are wearing for the leftover item after the end of the period. So simultaneously holding and shortage will not happen in this, in the short period model. So here the total cost can be either the purchase cost, because in this we are not taking the setup cost. Setup cost we have taken as a k is equal to 0. So purchase cost plus plus holding cost, or or purchase cost plus shortage cost. If the demand is less than desired inventory level, if demand is greater than desired inventory level. Clear this part? Actually, this is important here. Any doubt to understand this? How I am writing the TC? Now, from here, we compute the expected TC, expected total cost, and that we want to minimize. Minimize so that you can get the optimal desired inventory level. Means how much we should stock in advance. How much we should stock in advance before starting the period. So when we take the total cost, so total cost will become cost of the purchase plus expected holding cost plus expected uh, expected shortage. So in this case, purchase cost is what? C naught into Q, whatever the quantity you have purchased into the unit price. So C naught into Q. Since X is random in nature, random in nature or continuous random variable. So here the expectation will become C1 into value into probability, so R minus X into Fx. Then that is the expected holding item into the C1 unit holding cost. That will give you expected holding cost, complete holding cost. And you have to hold only when demand is lesser than the R. If demand is lesser than the R, then only hold you have to hold. Then C2 into X minus R. X minus R means when demand is greater than the desired inventory level, into Fx into dx. When demand is greater than R, then there is the shortage. So expected shortage will be the integral R to infinity X into R into Fx, means value. It is the value into probability. So it will be the total expected cost. Any problem to understand the how I'm writing the ETCR? Now I have to minimize this. I have to minimize this to compute the R star. So for that, what I have taken, let GR is equal to, I have assumed that this quantity is the GR. This quantity is GR. So let GR is equal to C1 integral 0 to R minus X into Fx dx plus C2 R to infinity X minus R Fx into dx. So ETCR will become C naught Q plus GR. And Q is what? Q is the desired inventory level, right? Here we have written na, Q is what? Q is the desired inventory level minus initial inventory. Initial inventory. So here we have written the Q is equal to R minus I. Q is equal to R minus I. Clear? So here we have the R minus I plus GR plus GR. Now we want to minimize the ETC. So when we have to minimize the ETC, it means del ETC by del R should equal to 0, and del 2 del 2 ETC R by del R2 must be greater than 0. Only then ETC will be the minimum. So here for the minimum ETC, ETCR, del ETCR by del R must equal to 0, which gives the R is equal to R star. That will give you the optimal value of the R. So in this case, what is the derivative? So here, from here we have the C naught R. So here you will get the C naught. Now in this case we have the C1 into R into Fx. C1 into R into Fx. So when we take the derivative, we have the C1 integral of 0 to R, 0 to R, or you can say R star of the Fx. Then here we have the minus R Fx and C2. So integral will come minus C2 integral R star to infinity Fx dx is equal to 0. As we do the is equal to 0, R will become the R star. So this will give you C naught plus C1. What is the integral of the small fx? That is the capital Fx. That is the CDF. CDF 0 to R star minus C2. What is the integral of the small fx? That is the capital Fx, CDF. And here we have the R star to infinity. So this will come C naught plus C1. Now F R star F R star minus F of 0 minus F of 0 minus C2 and f of infinity minus f of r star. F of r star. So can you tell me what is the value of the f0? Anyone? What is the value of the f0 and f infinity? What is the lowest probability and what is the highest probability? Yes, it's the 0 and 1, right? It's 0 and 1. So it is the 0 and it is 1. So from here, what you have, the c naught plus c1 fr star minus c2 1 minus fr star fr star. So from there fr star will come, right? It is equal to 0. It is equal to 0. So when it will give you fr star is equal to what? It is the c2 minus c naught upon c1 plus c2, right? It will give you fr star as c2 minus c naught upon c1 plus c2. And fr star is what? Fr star is what? That demand x is less than equal to r star. Fr star, it is the cumulative probability at point r star. It denotes that probability x is less than equal to r star, right? So here in this way we can compute the, so it means r star will become here, from here r star will be the f inverse of the c2 minus c naught upon c1 plus c2. So in this way we can compute the optimal desired inventory. Now for the fr star, this you know that it is the probability. It is the probability. If it is the probability fr star, we have taken fr star we have taken as c2 minus c naught upon c1 plus c2. So it since it is the probability, since it is the probability, so it must be the positive, because we know that probability always lie between 0 and 1. So it must be positive. So when it but we can have the chance of the negative also, because we have the c naught minus c naught, right? Due to the presence of the minus c naught, we have the chance of the negative also. But here we have always the c2 greater than c naught. Always we have the c2 greater than c naught. What is the c2? C2 is the shortages. C2 is shortage cost. Shortage cost, and C naught is purchase cost. Purchase cost. Purchase cost. So shortage cost always valuable, more valuable than the purchase cost. Otherwise, we will not do the business. Means you can understand that we take the food only when we feel the hungry. Means the भूख लगती है when then only we take the food, राइट? यदि भूख ना लगे तो हम खाना भी ना खाएं. तो हम खाना तभी खाते हैं जब हमें भूख लगती है. सो इन द सेम वे यू कैन अंडरस्टैंड दैट until we will not purchase the item, right, we are not facing the problem of the problem from the shortage. मतलब हम shortage we cannot manage. Shortages we cannot manage, right? Up to that we will not purchase. So means shortage cost always we have to consider greater than the c naught. So when the c2 greater than the c naught, so always the c2 minus c naught will be the positive quantity. So here we have the c, if the c2 less than equal to c naught, the above equation cannot hold. Hence this model is to be discarded. However, it is reasonable to assume C2 greater than C naught, since if C naught is the penalty cost unit is not greater than the C naught, then purchase production cost per unit, there is no point in purchasing or in producing. Means if the penalty is not greater than the purchasing, nobody will do the business. So here such an item otherwise purchase is made to avoid the shortage. means we are purchasing the item to avoid the shortages. Now we cannot tolerate the shortages, then only we go for the purchasing on item. So always it is reasonable to assume C2 greater than the C0. If somewhere it is given to you C2 less than C0, means or straightforward you can discard, you can discard your model, means this model is not a correct model. So all it is always reasonable to assume C2 greater than the C0. So when the C2 greater than the C0, so here you have the right here, here now you can say that C0 is greater than the right, C0 is C2 is greater than the C0. So C2 minus C0 upon C1 plus C2 will be the always positive. Now here we have the here we have seen the first derivative is equal to 0. So first derivative is what? First derivative is the C0 plus C1 into FR star minus C2 minus FR star. So here we have seen we have the del etc by del r is what? C0 plus C1 FR star minus C2 1 minus FR star. FR star. So if you compute here from right, so del 2 etc by del R2. So it is 0 plus from here we have the C1, from here we have the plus C2, and derivative of the capital F is the small, right, small f, or you can say x or r, small fr star. So in this case C1 is C1 C2 is always positive. First you assume C2 is always positive. It is the PDF, F is the PDF, always positive. So and we want this quantity must be positive. So for being a positive, C1 must also be the positive. C1 is what? C1 is the holding cost. C1 is holding cost. So holding cost can be negative. Holding cost can be negative, but we want the holding cost must be the means this quantity C1 plus C2 must be the positive, because F is positive uh, and C2 is positive. Holding cost can be negative as well as the can be positive. What is the holding cost? Holding cost means cost associated, cost associated to leftover item, leftover item, cost associated to leftover item. So if it is the newspaper, if it is the newspaper, you can sell the remaining newspaper to the garbage people, so in that case it is the negative, means you are earning something from the leftover item. But if it is the perishable item, you have to pay some amount for washing the storage area, you have to pay something to the super, right, to the cleaning people, uh, for washing the area, for throwing the garbage, you have to pay something. That is the salvage value, right? So in this case, when you are right, so means when we are getting something, right, salvage value, then we have to, when we are getting something, then this cost will be the negative. when we are when we are investing something, then it will be the positive, right? When we are getting something, then it is the salvage value. When we are investing something for the leftover item, then it is the positive. But whatever you are getting, that is always lesser than the C1. C1 is always lesser than the C0. C1 is always lesser than the C0. because nobody will give you more more amount than the purchase price, right? For example, you have the old newspaper, nobody will give you the 5 rupees, 5 rupees whatever the cost price of the newspaper. For the old newspaper, for the old newspaper, nobody will give you the more amount than the cost price. Always the salvage value is lesser than the cost price, right? So C1 is whether it is the negative, but right, so C1 is lesser than the C0, and already we have seen that C0 is lesser than the C2. Already we have seen that C0 purchase price shortage cost must be greater than the shortage cost must be the greater than the purchase price, then only you will go to business. So C1 plus C2 will always be the positive. Hence, C1 plus C2 will be always the positive, whether the C1 is negative or positive. It is immaterial. So now you can see that this quantity is coming positive. This quantity is coming as a positive. C1 plus C2 FR coming positive means it implies that we have the minima. By the calculus, it implies that we have the minima. So here it will give you del 2 etc by del R2 is equal to C1 plus C2 into f of R. So even C1 is negative, even the C1 is negative, C1 plus C2, C1 plus C2 is always positive. So that will be the greater than 0. C1 can be negative in case of ending inventory can be sold at the salvage price which is usually smaller than the C0. Means leftover item can be sold at the salvage price. Salvage price means it is the salvage value, right, which is always smaller than the C0, hence smaller than the C2, hence C1 plus C2 will become positive. Thus, the graph of ETCR is concave upward for all R. Thus, ETCR is minimum at the R star. Hence, R star is equal to F inverse C2 minus C0 upon C2 plus C1 plus C2. Means here we have the graph of the ETC. It is the graph of the ETC, ETCR, and here we have the R star. It is the R, and here we have the ETC. So you can see that you can see from the graph that it is convex in nature and minimum value at the R star. So from here we can conclude that C1 is always lesser than the C0, lesser than the C2. So that is true only for the probabilistic model, right? For the short period model. Now, so here, what is the meaning of the FR star? FR star means it is the probability. Means it is what? It is the X less than equal to R star. So it is the probability that no stock out means whatever demand, all the demand you are able to fulfill. Probability of no stock out means no shortage when the desired inventory level is at the optimal level. From here, if you have to compute, if you have to compute the if you have to compute probability x greater than r star, that is the 1 minus probability x less than equal to r star, that is the 1 minus c2 minus c0 upon c1 plus c2 upon c1 plus c2, that will give you c1 plus c0 upon c2 plus c1. So it implies that demand is greater than the inventory level. So it give you the probability that at least one shortage is there when the inventory is at the optimum. Means here we it represent that c1 upon c1 plus c0 upon c1 plus c2 represent that there is at least one shortage. So in this case, optimal inventory will be what? It is the q star. Q star is what? R star minus I. So that we are demanding. So here that much order we have to place. That much order we have to place. So in evening class, we continue with this from here. If you feel any doubt, you can ask at any point. Because so many conceptual things we have discussed. So if you feel any doubt, you may please ask.
Sir,
Yes.
sir, till where is the midterm syllabus, sir?
Where is the
Midterm syllabus.
mid-sem semester? This chapter. Whatever the tomorrow, whatever I will discuss up to that.
Okay, sir. Okay. Thank you. Thank you, sir.
Okay.